Hi, this is Eric from Rare Waves, and in this video we'll show you how to use precision hand tools to make the control panel for electronic chassis such as this right here. This is the Grendel Drone Commander 2 2019 limited edition, and I make these all by hand, and I want to share with you some of my techniques for working sheet metal to make a control panel such as this. And the material that the control panel is made from is aluminum 1/16 inch thick 5005 alloy. It's pre-anodized. You can see this is the reverse side with mill finish, and this is the show face with a protective plastic film applied to it. The tools I'll be using are the shear, the pan and box brake, and the punch press. In addition, there's a couple hand tools for measuring and marking: the automatic center punch, a jeweler's loop for visual magnification, an adjustable protractor, a tri-square, and a dial caliper. I'm sure you're already familiar with power tools for sawing, drilling, and milling. What distinguishes these hand tools for sheet metal working is that they're hand operated, and that means that they're quieter, more efficient, possibly safer, and they use no electricity. The only electricity being used on this workbench is for the overhead light. The parts of this project begin with a stock sheet of aluminum, and this material comes in 12-inch wide strips which perfectly fit the 12-inch width of this grizzly shear that I'm going to use to cut the blanks. And it's a pretty simple operation if you know what you're doing. First, you start out by scribing the line of the cut on the sheet with a dial caliper, and I'm not going to actually mark on this piece because this is just a demonstration, but you do that by setting the width of the cut on the caliper dial and then dragging it across the workpiece to leave a scribed line. And then it goes into the shear, and very carefully line up the scribed line with the blade, and then I'm not going to cut this piece actually, but then it's just a matter of pulling down and it cuts right through that sheet, and you end up with a blank. After cutting the material to size on the shear, we have blanks that are going to form our top panel. I've got them in black anodized and natural anodized 1/16 inch aluminum, and you can see on the reverse side I've applied a template that was printed on the inkjet printer, and that's the only CNC machine, as you might call it, that we're going to use in this project. The next step is to get ready to transfer this pattern into the material using the center punch, and to do that I use the automatic center punch and a jeweler's loop to assist me in positioning the holes in the right spot. Now let me show you how I use the jeweler's loop and the automatic center punch to position the center marks for the punch tool. Just really carefully position the tip of the punch on the center of the printed mark, press down, and the automatic center punch does the rest of the work to make a tiny little divot that's going to guide the tip of the punch press. And I just carefully proceed to do all the rest of the center marks on this workpiece. Now I'm ready to move on to the punch press, where we can start removing material to finish our cutting operations. And the first thing I'm going to do is to take off the sharp corners on this workpiece. And the punch press has a set of tools for corner radiusing, and what that's going to do is it's going to cut off the sharp right angle corner and leave us with a rounded edge. And in this case I'm using a 1/8 inch radius tool, and the punch press is very simple to use, and it's also a very safe tool to use. Since nothing is spinning, there's nothing sharp, you actually don't even need to clamp the workpiece. You can just position it by hand, and here, just in that operation, I've simply nipped off a rounded edge from the corner of the sheet metal, And I've got Mr. LaForge supervising the operation. Make sure I do everything right. I'll just go ahead and do the other 3 corners. Yep, there we have a 1/8 inch radius on all 4 corners of this blank. One great thing about the use of punch and die tooling to form holes in sheet metal is the ability to form holes that aren't necessarily round, or the punch and die can be arbitrarily shaped, and in this case we're using what's known as an Obround. It's an oval shaped hole, and here is the die which goes beneath the workpiece, and here's the punch. The punch tip simply pierces through the workpiece and goes into the die and cuts out a slug. And when you're done, here's the results. And that's a lot different than a sawing or milling operation, which results in a whole bunch of sharp bits of chips or sawdust. Tool changing in the punch press takes a few minutes. With a little practice, first I'll loosen the die holder, then I'll remove the work table. Now the die holder can come out, and take the die out. Next, out comes the punch adapter. And then we'll just remove the punch tool. Now we can put away the 1/8 inch radius punch that I just used. So the next step is going to be to use this tool set, and these are made for turret punches. And since this isn't a turret punch, I've got to use a tool adapter, and this was made by my friend Jesse over at Animodule. And the purpose of this piece right here is to allow me to use turret punch tooling in the single station press. So first, I'll mount the adapter on the ram. And then in goes the tool. And since this is a shaped punch, it's the Obround I just showed you, the orientation matters. And to help assist me to get it lined up straight, I just place a ruler flat against the flat edge of the tool before I tighten down the texture. Now that punch is mounted securely, and I'll just put the die in the die holder. It drops back in the base, and next I'm going to line them up together. Looks like we need to tighten that a little further. Alright, it's tight now. Okay, just very carefully get the punch tip into the die. I'm going to try to square up the table a little bit and tighten the die holder. And the work table is fixed back on the base of the press. That's secure. Okay, now it's got free travel of the die and the punch. Before I can start punching, I need to make sure that it's lined up straight. So to do that, I have a little trick that I use. I use this tri-square to find the true angle of the punch tool in the press. So I just rest the tri-square against the flat edge of the tool, seat it. Now you can see that it's not really right angle with this work table, but to compensate, it's pretty simple since I have an adjustable protractor. And I'm going to line that up perfectly with the true angle of the tool and lock it in. Okay. So now I've got the exact angle of the tool dialed into my adjustable protractor, and by using the front edge of the work table to guide the protractor, I can position my workpiece so it'll get a square, a lined up square with the tool every time. I'll just make a test cut right here. And there we have our Obround hole. Before I start cutting, I'll put a little drop of oil on the punch and die to keep things working smoothly. And now here's where the center punch that I used earlier comes into play. You see all of the holes that I'm going to punch are marked with a little divot, and the tip of the punch tool has a tiny point, and that'll slides right into the center mark. And since this is a shape tool, I need to make sure I have it lined up at the correct angle. That's why I'm using this adjustable protractor. Now the hole is cut. It's very quick, very safe. Punch tooling really shines when you need a rectangular hole. For instance, here there is a rocker switch that's going to be mounted in this chassis, and a rocker switch needs a rectangular hole with perfect corners, and something like that would be very difficult to do with a CNC machine since the bit has a radius intrinsic to it. But with a punch tool you can make rectangular holes of basically any size. And in this case, my tool doesn't match the actual size of the part, but with punching, it's okay to overlap the punch because it's not spinning, and so it's safe for multiple holes to overlap each other. And so in this case, I've mapped it out where 4 punch operations will give me the size that I need to mount this rocker switch. Now we'll go ahead and make our arbitrarily sized rectangular hole using 4 overlapping rectangle punch operations. And having the layout just perfect is really important in doing this, and so I found that using adhesive labels with an inkjet printer to transfer the pattern onto the workpiece is working good for me. My inkjet printer is the only CNC machine that's involved. And here we have an excellent rectangular aperture. Another example of shaped tooling that works well in the punch press is a round hole with one flat edge, and that's commonly used for a DC power connector such as this, or any round feature that needs to prevent it from rotating inside its hole. So you can see in the profile of this plastic part there is one flat edge to the threads, and that's what keeps it from twisting out while it's in use. And take a look at this die. It has that flat feature formed into it, and we can just verify that when I put this DC connector in there, it doesn't twist when it rotates. And so here's the tool set that's used for making round flat holes. For making round holes, the punch press is really smooth, and all it takes is lining up the point and the tip of the punch with your center punch mark, and then it comes out very clean, much safer and faster than a drill press, and probably easier to set up than a CNC machine. Now that just turned out real nice. Here is the potentiometer that we're going to be using in this chassis, and to make sure we have selected the right tool to produce the hole that it's going to mount in, it's going to measure the bushing really quick. The bushing measures 0.265, and I have the 0.275 tool ready to go. And the other factor that matters is the die clearance. That's a little more complicated issue. We can measure the die clearance here. You can see that we've got 7/1000 of an inch die clearance, which is appropriate for 1/16 inch aluminum. If you've been browsing shop videos on YouTube for a while, you've probably seen various versions of the demonstration on how to drill a square hole. Well, here's my version of it, except we're not drilling, we're using a punch and die. And the part that I wish to use on my panel is a square LED, and of course there's no drill bit that drills a square hole in sheet metal, but a punch tool does the job admirably. And here you can see that I've got a custom made square punch and die that fit this 5mm square LED just perfect, and that's what we're going to use to make the holes in our panel. I'm finished with the punch press, and you can see the stack of panels that I've created. If you look up close, see that the hole pattern is pretty consistent from part to part, and that is the benefit of using the automatic center punch and the printed labels to mark the hole positions. Next step will be to form these into the shape that is specified in the drawing, and to do that I'm going to use the pan and box brake. This is what's known as a pan and box brake, and it's used for bending sheet metal. In this case, what we want to do is put two right angle bends in this panel, so it's going to form a C profile when it's done, and that's basically done by placing it, by clamping it under the fingers of the brake, and then bringing up the bending bar to form the bend. Now, before I go and start bending the actual workpieces, I'm going to do a quick sanity check, and for that reason I've prepared a test strip, and on it it has the same printed adhesive label that I used to prepare the workpieces, and these are the marks that I'll line up on the brake, which should give me the result that I'm after. And I'll also confirm that I have the brake set up with the proper setback. My specification in the document is 95 thousandths of an inch, and I'll just measure it here. What do we get? That's about 99 thousandths, fairly close. Measure on the other side, double check. 93 thousandths. That's pretty good. It's a little tricky to measure that exactly anyway, so I'm just going to assume that that's fine. And now, very carefully, line up the edge of the brake finger with the printed line on the test strip. And just to be real sure, I'm going to use this loop to make sure I've really nailed it. I'll go ahead and make the bend. And proceed to the other side. Bend number 2. Now let's see how I did. Just to make sure that the angle is alright. You can see it was overbent just slightly that time. And there it's also slightly overbent, but it's easy to bend it back a few degrees. But what really matters is that the dimension matches what the specification in the document. So in here I'm looking for 4.835 inches inside measurement on this flange. What do I get? Well, 4.858. And that's about 25 thousandths too wide. Of course, that's better to be a little wide than it is narrow. So, it's smart to do a test strip. Well, I'll go ahead and bend the first workpiece. It's always a little nerve-wracking at this point since I spent so much time preparing it. But to help me get the angle right, see, I've got a protractor magnetically fixed onto the brake leaf. And now it's just a matter of lining up the fingers exactly where they ought to be. I've also put some blue tape on the bending leaf to prevent scratching the work surface. So I take my time doing this because there's no way to undo it. Okay, it looks fair enough. I'm feeling brave, so clamp it firmly and let's bend. There's the matter of spring back of the workpiece, so normally I want to overbend by a degree or two, and that protractor helps me do that. Helps me get that overbend just right. Now, how's the angle? The angle looks pretty good. Well, do the next one. Double checking I've got it lined up straight. That looks pretty reasonable. Clamp it down, and here comes the bend. .852. Oh, that's not bad at all. 4.86. Yeah. Pretty cool, buddy. Next order of business is to remove these adhesive labels from the parts, and to do that I'm using this Goo Gone Automotive Goo and Sticker Remover. It's a pretty good product. I sprayed it on, let it sit for about half an hour, and that releases the adhesive pretty well. So we'll just peel away the paper. There's a little bit of gunk left, so I'll just let it soak a little while longer in the Goo Gone, and then it's just a matter of some scrubbing and detergent with water and soap to clean up these parts. Skipping ahead to the very end here, here's an example of the finished chassis that's been put together. Here's the base of it, with the circuit boards mounted inside and oil finished cherry end cheeks. Here's our panel that we've just made, and the electronics are mounted in it. We'll connect it up together just to see it all come together. It's a tight fit, but once the screws are tightened, there we have it. Thanks for watching.